Okay, so having gone so far, we can do our first example now. So we are given a die, and we're going to roll it 6 times. Okay, let's make some assumptions about the rolls. Let's assume that the rolls are independent. And that the die is also fair. So this means that the probability of any particular outcome of the die rolls, for example, so we have 6 rolls, one particular outcome could be 3, 3, 1, 6, 5. So that's one possible outcome. What's the probability of this outcome? There's probability 1/6 that this happens, 1/6 that this happens, 1/6 that this happens, and so on. So the probability that the outcome is this one is 1/6 to the 6th. What did I use to come up with this answer? I used independence, so I multiplied the probability that the first roll gives me a 2 times the probability that the second roll gives me a 3, and so on. And then I used the assumption that the die is fair, so that the probability of a 2 is 1/6, the probability of a 3 is 1/6, and so on. So if I were to spell it out, it's the probability that we get a 2 in the first roll times the probability of a 3 in the second roll times the probability of a 5 in the last roll. So by independence, I can multiply probabilities, and because the die is fair, each one of these numbers is 1/6 to the 6th. And so the same calculation would apply no matter what numbers I would put in here. So all possible outcomes are equally likely. Let's start with this. So since all possible outcomes are equally likely, to find an answer to a probability question, if we're dealing with some particular event, so the event is that all rolls give different numbers. That's our event A. And our sample space is some set capital omega. We know that the answer is going to be the cardinality of the set A divided by the cardinality of the set omega. So let's deal with the easy one first. How many elements are there in the sample space? How many possible outcomes are there when you roll a die 6 times? You have 6 choices for the first roll. You have 6 choices for the second roll, and so on. So the overall number of outcomes is going to be 6 to the 6th. So number of elements in the sample space is 6 to the 6th power. And I guess this checks with this. We have 6 to the 6th outcomes. Each one has this much probability, so the overall probability is equal to 1, right? So the probability of an individual outcome is 1 over how many possible outcomes we have, which is this. All right. So how about the numerator? We're interested in outcomes in which the numbers that we get are all different. So what is an outcome in which the numbers are all different? So the die has 6 faces. We roll it 6 times. We're going to get 6 different numbers. This means that we're going to exhaust all the possible numbers, but they can appear in any possible sequence. So an outcome that makes this event happen is a list of the numbers from 1 to 6, but arranged in some arbitrary order. So the possible outcomes that make event A happen are just the permutations of the numbers from 1 to 6. So one possible experiment that's going to make our event one possible outcome that makes our event to happen would be this. Here we have 6 possible numbers, but any other list of this kind in which none of the numbers is repeated would also do. So number of outcomes that make the event happen is the number of permutations of 6 elements, so it's 6 factorial. And so the final answer is going to be 6 factorial divided by 6 to the 6th.